Hello everyone, welcome back to my YouTube channel, and today I will be teaching you about the electrochemical cell. In an electrochemical cell, chemical potential energy is basically converted into electrical kinetic energy. Okay, so in this lesson we will be studying about three electrochemical cells. The first one is the Daniell cell. The second type is the dry cell, and the third type is the lithium ion battery. One thing we have to establish before going into these three things is that electrochemical cells are divided into two types. Primary, which have irreversible reactions. And secondary, which have reversible reactions. So let's take a look at our first example, which is the Daniell cell. Daniell cell is mostly a primary electrochemical cell. Okay, so let's draw a diagram of a Daniell cell, or just a general electrochemical cell. This is our anode, cathode. We have some electrical wires over here. We have a salt bridge, which is made of potassium chloride, and we have some electrolyte. Let's just label this KCl. Now, here in an electrochemical cell, as opposed to an electrolytic cell, the cathode is positive, the anode is negative, and electrons will flow from the anode to the cathode. Okay? And the anode and the cathode are both connected by a voltmeter. The cathode will always have a less reactive metal than the anode, because more reactive metals give electrons to less reactive metals. So for electrons to flow from the anode to the cathode, we require the anode to be more reactive. So in our Daniell cell example, the anode will be made out of zinc, have an electrolyte of zinc sulfate. The cathode will be made out of copper and have an electrolyte made out of copper sulfate. So now that we have our cathode, anode, electrolyte, and salt bridge established, let's start with the reactions. At the anode, the zinc turns into a zinc ion plus 2 electrons. At the cathode, copper ion converts into copper. And this is done through the help of 2 electrons. Okay, so now if we cancel all the like terms, so we cancel 2 electrons, we're left on the reactant side with zinc and copper ions, and the product side with zinc ions and copper. So the final reaction will be zinc plus a copper ion turns into a zinc ion plus copper. This releases a charge of 1.1 volts. Now let us move on to the next example, which is the dry cell. Dry cell is a special example where the cathode is actually not very reactive. It doesn't take part in the reaction basically. So let's draw our two beakers again. This is the anode, this is the cathode, and this anode is actually made out of zinc again, and this is made out of graphite. Again, they're connected using a voltmeter. We have a salt bridge to balance the charges. And here they have some dry electrolyte, hence it's named dry cell. So instead of having a liquid electrolyte, it has a very dry electrolyte. Now, this electrolyte is ammonium chloride. In its chemical form, you can see it like this. Now let's take a look at the reactions. Now, one important thing to remember about dry cells is that they aren't completely dry like powder. Their electrolyte is sort of pasty. And this pasty electrolyte has many different components. Now, some of these components are magnesium oxide, water, and carbon. So, at the anode, a zinc plus 2 ion will react with our ammonium chloride and 2 hydroxide ions to give rise to a diamide dichlorozinc complex. That is represented here. And it also gives rise to 2 water molecules and 2 electrons. Now at our cathode, our magnesium oxide reacts with water and 2 electrons to give rise to manganic oxide, 2 hydroxide ions, and that should be it. So now if we take a look at both of our reactions and try and find some common terms, we can see that on the product side we have 2 electrons common, and so we will cancel that. And on the reactants we have 2 hydroxide ions common, so we can also cancel that. So our final reaction will be zinc plus magnesium oxide and 2 ammonium chloride will give rise to a diamide dichlorozinc complex, two water molecules, manganic oxide, and that is all. Now the dry cell is a little complicated, but it is a very important cell in the form of batteries, because it was one of the earliest batteries to be invented. Now, the salt bridge in the dry cell acts as it would in all other batteries. It is simply there to just maintain a charge between the two, so there isn't an excess of charges in one. Okay. Now moving on. The last electrochemical cell we will be covering here today is the lithium-ion battery. Keep in mind that while the previous one we just covered, the dry cell, was a first degree electrochemical cell, this is a second degree electrochemical cell, so it is rechargeable. So let's take our example with two beakers with an anode and a cathode. And this time we have a liquid electrolyte. Yeah, see, it is just representing that it is a second degree electrochemical cell or secondary electrochemical cell. We have a salt bridge. And here I'll just represent the voltmeter with the letter V. And it connects both the anode and the cathode. Now here, the anode is graphite. And you might have noticed that the cathode was graphite in the previous cell, see, here, but the graphite doesn't actually have any involvement in any of the chemical reactions, as you can see. It is simply there to allow for electrons to pass through because it is a conductive material. Now the cathode for this cell will be cobalt oxide, and the common electrolyte for both will be lithium carbide. Okay, so at the anode, what happens is our lithium carbide, one second, let me just redraw that. Yeah, so our lithium carbide converts into carbide plus a lithium ion, positively charged, and an electron. At the cathode, our cobalt oxide reacts with our lithium ion and our one electron to reconvert it back into lithium cobalt oxide. So our final reaction when we cancel the electrons will become lithium carbide plus cobalt oxide converts into lithium cobalt oxide plus carbide, and that is our final reactions. Anyway, those are the three types of electrochemical cells we're covering in this video. If you liked it, please hit the like button, and if you have any doubts or want me to cover anything else, please leave it in the comments below. Thank you for watching, and please subscribe. Bye.